Hello everyone, welcome to this video where we're going to look at how we can introduce pinned constraint lines to effectively pin shell edge connections to one another. And this may be useful if we have systems that may be comprised of shell elements that we don't want to transfer moments and have rotational continuity between those adjacent objects. So to demonstrate this here, I'm starting with a model that has two coplanar panel elements. And these panel elements themselves are not finite elements, but they are used to generate finite elements down the road. And so what we can do here is we can see here that we can actually mesh these elements. I'm just going to click the mesh button. It's going to produce a mesh, as we can see here. I'm going to accept this mesh. I'm going to apply some supports to the outside, just on the edge here. And then under the loads window here, I'll go ahead and I'll apply a load of -1 kPa to all of these shells. I'll run an analysis, a linear static analysis, and after the analysis is finished, with my existing model here, I'm just going to look at the results for that load case I created. And here I can get an idea for the deflection of this set of shells based off the applied loads. I should mention as well that I'm using a steel material and a 10mm thick shell element here. So we can see here that, if I maybe I'll go to the side view, we clearly see that it's acting as one continuous piece of steel, essentially, and we just discretize it with these shells. But that may not always be our intention. Maybe we have two pieces of steel that are hinged together in the middle. And if we want to represent that, well, we can go about that process as well. It's just done a little bit differently. So I'm going to go to the geometry window, and I'm actually going to get rid of these shells using the quadrilateral element tool. I'll hold down Control, and I'll left click and drag my mouse around these shells to get rid of those shells. And I'll do the same thing with the existing joints that are left over. Hold down Control with the joint tool and left click and drag to delete. And finally, I've got some supports as well in those existing joints that are remaining. So I'll just select the support tool, hold down Control, left click and drag to get rid of those. So now I'm back to essentially square number one. And what I want to do is I want to introduce a release, a moment release between the shells that are going to be produced on this edge here, where my two panels meet. And to help with this, I'm just going to shrink the elements for visual check so I can see where that set of joints are that I want to connect between. And what I'm going to do is I'm going to use the member definition tool. I'm going to left click on the member definition tool. And from this member types drop down at the top of the screen, I can scroll down until I find the pinned constraint line member type. So I'm just going to left click on this option and draw this in just like any other type of member I would draw. Now this member itself is not a physical member from a structural sense, in the sense that it's going to provide stiffness or mass, but it is going to tell those shells that I'm going to produce during the meshing process how to behave in terms of their connection to one another. But I still have to do one more thing. I need to make sure that here, if I go to the member release tool, I want to assign a member release. And I can assign this member release to one or both ends. I'm just applying it here to just the one end here. And it's in the MX direction. And this just tells S-FRAME which panel should be released. And this can be helpful if we want to perhaps connect non-coplanar panels. We can control which panels are being released and which ones aren't. But I've set this up with a coplanar panel, so I don't really have to worry about that. For more details on that, however, you can go visit our help system on this topic. But now, essentially what's going to happen is when I mesh, S-FRAME is going to be instructed to create a release between the shells at this line here. So I'm going to go ahead and run the meshing process now. Click Mesh Panel Elements, type Membrane Plate or Shell. Have the same message here to accept my mesh, and click OK. I'll unshrink my elements just so we can see what we're working with. This looks just like we had before. I'll go ahead and reapply my supports since I've regenerated all these nodes. And I'll go ahead and also create my loads. So under the test load case here, since I deleted those shells that had the loads applied to them, I'm going to reapply those loads. -1 kilonewtons per meter squared. And I'll rerun the analysis. Once again, a linear static analysis, click OK. You get a clean solution. And now if I look at the results, here the deflected shape is going to show me a much different looking deflected shape. It's very clear to me that I do have a pin. There's no rotational continuity or moment continuity between those two panels. And maybe just to look at this from the side view, it again is clear to me that what's going on. I could also look at some of the other contours if I'm interested. So hopefully this can be of use to you if you're working with these types of panels. Perhaps you're working with CLT panels, for example, that need to be moment connected to one, or pinned, sorry, to one another. This can be a useful tool for you. If you have any questions about meshing or you want to see more information, feel free to reach out to our support team or visit our YouTube channel for some more helpful tips.